This is our home planet Earth and its satellite, the Moon. Zooming out, and here's our solar system. A bit more, the Milky Way galaxy. And we're a small dot among an infinite number of stars. Now, even farther out, a cluster of galaxies. Dots and swirls in the endless space. Further, there's Laniakea supercluster. That little dot here is our galaxy. Moving on, Hydra Centaurus supercluster. Huge clusters comprising thousands of galaxies are no more than a speck from here. Next, Pavo Indus supercluster. This is an area 200 million light-years wide. We can zoom out until we see the entire observable universe. Each little dot in here actually contains thousands of galaxies and quadrillion stars. Scientists speculate that our universe may look like a bubble, and that bubble might collide with another universe. Yes, other universes could exist. Actually, even a whole infinite number of those. All of them could have appeared after the Big Bang. The collision between them isn't impossible either. At least, it might have happened before. And the proof is here, in the direction of the constellation Eridanus. This place is called Eridanus Supervoid. It's about 1 billion light-years wide. By comparison, the width of our entire galaxy is only about 100,000 light-years. There's absolutely nothing in this place, and it may be a trace from an old collision between our universe and another. Scientists think they were passing by each other. When the distance between them was minimal, the gravitational forces of the bubbles began to pull toward each other, just like two drops of water trying to connect when they're close. But the speed of the universes was too high for them to continue interacting, so the other universe just tore out a piece of our bubble. There might have been about 10,000 galaxies in that void, and all of them were either destroyed or taken over by the other universe. Let's travel to the edge of our universe to see how this collision might have taken place. We're 10 billion light-years away from our home. Here, in another galaxy, we see amazing nebulae of different colors and shapes. And if you look in the other direction, there's a huge wall moving at us. All these bright sparks on it are enormous galaxies about to collide with us. But in fact, it's a humongous mirror that only reflects our universe. Here, space-time is distorted and begins to be pulled into another universe at a tremendous speed. The usual law of physics may simply stop working at this point. Gravity may disappear, and with it, all the stars would explode and people on the surface of planets would hang in weightlessness. But if the universes didn't go at a tangent but crashed directly into each other, things would be much scarier. The enormous amount of collision energy would probably cause an incredible explosion. Its force would simply destroy everything in our bubbles. Still, the two bubbles might begin to merge too. At first, all galaxies at the edge of the universes would be torn apart. But then, the merger would begin. The galaxies would start moving chaotically. They would fly past each other, break apart, collide, and explode. The collision of two galaxies is an accident of enormous proportions, and it might happen to our home quite soon, in space terms. The Andromeda galaxy is heading our way. It's a spiral galaxy about twice the size of ours, and there are about 1 trillion stars there, which is twice more than in our Milky Way. At the very center of this bright galaxy lurks a dark beast, a black hole. Its weight is 2 and 8 zeros of the Sun's mass. Red giants hundreds of times larger than our Sun. Pulsars emitting enormous amount of energy like spotlights. Rogue stars, and many large and small black holes. This soup of dangerous objects is moving toward us at 68 miles per second. A trip to New York to Los Angeles at that speed would only take half a minute. The disk of Andromeda can already be seen with the unaided eye on moonless nights. As time goes on, it'll get even bigger. As Andromeda gets closer to us, its gravitational force will begin to stretch the arms of our spiral galaxy. It'll begin to unwind. The stars and planets will lose their orbits. One possible scenario is that an unknown asteroid, or even a dwarf planet from the Andromeda galaxy, will crash into the Earth at an incredible speed. Our planet will explode just like a balloon from this impact. Oh, goody. Another option involves stellar collisions. Our Sun would face another star. The bigger star will slowly begin to consume the smaller one. First, it will steal the light upper layers from it, and then it will eat it just like spaghetti. Or even like rigatoni. When a large star reaches its critical weight, it will burst. This explosion will destroy everything around it, including our solar system. Perhaps the shockwave will even reach other neighboring stars. Yet another scenario is that our solar system will be thrown into dark space. Imagine a tennis ball tied to a rope. You take the rope and spin the ball over your head like a sling. Then you let go of the rope and send the ball flying. This is what will happen to the Sun and all the planets around it. We'll find ourselves in dark and cold space. But life on Earth will not be affected. We'll still have our bright star to keep us warm. The only disadvantage is that all the stars in our night sky will disappear. And the most likely possibility is that the merger of two giant galaxies will have no effect on us at all. The thing is, the distance between stars and planets in space is enormous. So they can all just mix together and form one giant cloud. It would be like shoveling fine sand through a big sieve. The objects won't interact with each other. But the most interesting thing will happen to the black holes in the centers of our galaxies. Right now, there's a dense cluster of stardust and stars around them. As Andromeda and the Milky Way come closer together, they will begin to dance with each other. Gee, will it be the twist or the foxtrot? And when the black holes get close together, they'll begin to swallow all matter around one another. Billions of tons of colored stardust, asteroids, and star particles will fly toward the very center of either black hole. It might seem like this process happens very slowly, but it's an illusion. Super heavy objects like black holes warp the space-time grid, so time is much slower near black holes. And all objects that seemingly stay on the event horizon for weeks or even months are actually long gone. When the black holes finally come together, they merge into one supergiant black hole, but its mass is slightly less than the combined mass of the two dark monsters. Some of their weight is transformed into collision energy. This energy is released so strongly that its waves can be felt in other galaxies. Now, a huge black hole gathers all this dense and hot core of the two galaxies around itself. At some point, the black hole feels full and throws out powerful jets of energy into space. This is called an active galactic nucleus. It's one of the brightest phenomena in the universe and the most powerful source of electromagnetic radiation ever known. These jets may be more than 5,000 light-years long. By comparison, the distance from Earth to the nearest star, Proxima Centauri, is only 4.2 light-years. And the explosion that accompanies the jets has the power of 100 supernova explosions. Wow, blows my mind. The blast wave from this event could even reach the edges of a new galaxy, and this outburst would be visible from millions of light-years away. Now, there are dense clouds of multicolored dust at the center of merged galaxies. The weight of these clouds is so great that they begin to shrink and take on a round shape. Gradually, they become so heavy that they compress the core and nuclear reactions start inside them. The temperature begins to rise and soon, boom, there's a supernova. It's a veritable fireworks show at the center of the galaxies. Stars erupt from the fog and form new hot worlds. At this point, the arms of the two galaxies that were previously pulled out slowly return to their former shape. The super-heavy center of our galaxy has such a gravitational force that it affects stars and nebula hundreds of thousands of light-years away. The galaxy's arms twist again, and we see the new and finished galaxy, the Milkomeda, or Milkdromeda. Hey, how about the Milky Way? Blah blah blah. Well, that's hard to say. Now, we all know that all planets are round. There are no square ones so far, and that's because of gravity. Well, roundish at least, as not all of the planets have perfect proportions. But did you ever wonder about the shape of the universe itself? Is it also round because of the same forces? Well, not really. Based on what information we have so far, the universe is actually flat? According to the principles of general relativity, space has the ability to curve. This opens the door for the universe to have three potential shapes: a flat plane like a sheet of paper, a closed sphere like a bowl, or an open saddle-like curve. This isn't just a matter of academic interest, you know. The universe's shape has direct consequences on its ultimate destiny. One cosmologist from Princeton University explained it beautifully. The shape of the universe is a kind of map to its past and a predictor of its future. The questions of whether the universe will keep expanding forever or collapse at some point, and if it's finite or infinite, all circle back to the question of its shape. Now, to wrap your head around this cosmic question, you need to understand two key elements: the density of the universe and its rate of expansion. Let's dig into this a little. Around 68% of the universe is made up of dark energy, while 27% is dark matter. The rest, which is normal matter, if you'd like, makes up the stars, planets, and other cosmic bodies we're familiar with. When we talk about the density of the universe, we're referring to the quantity of normal matter packed into a given volume of space. Now, if the universe is denser, it also has more gravity. In this case, the gravitational pull can overcome the force of expansion, so the universe curls up into a sphere. This shape is known as the closed model, where the universe ends up looking like a gigantic cosmic ball. Imagine a world that's finite but without boundaries, a contradiction for sure. In this model, an adventurous explorer could travel forever through space, never bumping into a wall or falling over an edge. Alternatively, if the density of the universe is low and not enough to halt the expansion, then space distorts in the opposite direction. This results in an open universe with negative curvature that resembles a saddle, like on a horse. Despite these two potential scenarios, most scientists agree that the density of the universe is just right, which means it expands proportionally without curving. But what does it mean if the universe is flat? It doesn't mean we're living in an infinite sheet of paper. To understand it, consider these analogies. Imagine you're in a square room, walk 10 steps to the next corner, make a 90-degree turn, walk another 10 steps, and repeat this process twice more. You end up back at your starting point, completing a square. Add another dimension to this geometry, since we're not 2D creatures, and whoopee, you have a flat universe. This analogy wouldn't hold up in a curved space. If you have a terrestrial globe at home, you might find it easier to understand this next experiment. Start by placing your finger at the Earth's equator, then trace a line to the North Pole, make a 90-degree turn, and return to the equator. Make one more 90-degree turn and walk back to your starting point. This journey only needed 3 turns, unlike the 4 turns in the flat universe scenario. Still struggling to understand? Here's another way to picture it. In a flat universe, 2 rockets traveling side by side will always remain parallel. This is in contrast to a closed universe, where the rockets will travel along the curve of space and eventually meet where they started. In an open universe with negative curvature, the rockets will gradually drift apart and never cross paths again. So, is there a cosmological crisis at hand? It seems the answer to the shape of our universe is encoded in the cosmic microwave background, also named CMB, which is like the universe's fossil record. Over the past few decades, scientists have measured temperature fluctuations in the CMB to find almost no curvature, indicating a flat universe. Now, the concept of a flat universe is crucial to the standard cosmological model. However, in late 2019, scientists from a university in Rome published a paper arguing that current CMB measurements actually indicate we're really living in a closed universe. How did they figure this out? Well, they looked at how light behaves in the universe. Specifically, they analyzed how light bends because of the gravitational force of matter in its path. Either way, apart from this finding, there's nothing else that would suggest we're living in a closed universe. Most scientists believe this recent discovery is nothing more than a statistical anomaly. But if the closed universe theory turns out to be right, it would shift decades of astronomical findings. If the universe is indeed curved, it must be so large that the observable 93 billion light-years aren't enough to reveal its curvature. It could be similar to standing in a fog, only able to see a small, flat patch of land. Yet somewhere out of sight, the horizon reveals that we live on a sphere. As we continue to probe the cosmos, we might find that the apparent flatness of our universe is just a small part of a much larger, curved cosmos. Its shape is just one of the many things we've yet to figure out about the universe. We can't quite put our finger on why the universe is even here, for instance. We do have some theories, but scientists are yet to be sure. It could be that the universe is like a pop-up, materializing out of an unstable nowhere land. Imagine the emptiest emptiness you can think of, suddenly churning out matter and energy in equal and opposite amounts that tally up to zero. For most of us, it's hard to picture that process. If we follow this theory, who's to say there's only one universe? We might be just one of an enormous collection, a so-called multiverse. For now, we'll just have to wait for the next wave of cosmic measurements to refine our theories, and for scientists to come up with hypotheses that aren't just mathematically pretty, but actually testable. Also, how could we possibly know all the secrets of the universe if we don't completely understand our own biology yet? I mean, if we did, we could, theoretically, solve all of our health problems, right? We might even be able to play around with our DNA, like this molecular Lego, and give ourselves naturally purple hair or red fingernails. Well, time for a reality check, as we're still struggling with this one too. Here's a great example: our microbiome. Our bodies, home to 10 trillion human cells, are also an active city for 100 trillion microbial cells. That's a couple of pounds of bacteria and other microbes, which we absolutely can't do without. They've set up shop in our bellies, lungs, noses, and every other hidden nook and cranny. We're like luxurious cruise ships for these tiny microbial tourists, and we still don't fully understand the implications of this symbiotic relationship. There are still a lot of things we don't know about planet Earth either. We've only ever dipped our toes into Earth's crust, never venturing more than a few miles deep. Everything else is our best guess, from remote sensing and smart physics. Believe it or not, it took us an embarrassingly long time to accept that the Earth's crust is constantly shifting, like Jenga pieces. We only warmed up to plate tectonics in the mid-20th century. We're also still trying to figure out precisely how the planet's inner engine works, and how the swirling, conducting materials in the outer core create our protective magnetic field. Plus, with 4.5 billion years of geological chaos, we're sometimes better off studying meteorites or the surfaces of other celestial bodies for clues about our planet's history. Even our faithful companion, the Moon, is a bit of a mystery. Was it born from a colossal collision or some other event? We're still not sure. But hey, the fact that we still have a lot to learn is what makes life interesting, isn't it? That, and the thrill of actually finding an empty parking spot in San Francisco, or maybe even your city.
You're traveling through deep space, circling stars and entire galaxies. Whoa, looks like this multicolored nebula will soon collapse under its own weight and explode like a supernova. Now let's carefully circle this black hole. Try not to get caught in its gravitational field, or it'll swallow you like a space monster. Wait, what's that strange structure right there? It's a glowing wall. And if you look closely, each glowing dot is an entire galaxy. That wall has about 100,000 of these galaxies. The Milky Way has 100 billion stars. So this wall holds a quadrillion, that's 10 followed by 15 zeros, of stars like our sun. This giant structure is called the South Pole Wall. It's located about 500 million light-years from Earth. By comparison, the closest star to our home is Proxima Centauri, and it's about 4.2 light-years away. Rockets can cover that distance in about 73,000 years. So the journey to the South Pole Wall may take longer than our solar system exists. And this wall is simply gigantic, even on a cosmic scale. It's about 1.37 billion light-years long. To give you an idea of how large that is, the Milky Way is only 100,000 light-years wide. But you can't see this wall even with the most powerful telescope. The problem is that the Milky Way itself obstructs your view. It's so bright that it's hiding this wall. It's like trying to look at the starry sky in a metropolis. The light pollution won't let you do that. Scientists have been able to detect this galactic wall by measuring redshift. We know that all objects in the universe are moving. They spread out from each other as a result of the Big Bang, which happened billions of years ago. And when galaxies move, their light waves change slightly. By measuring this change, we can understand what the object is and how it moves. And this wall isn't even the largest in our universe. This is the Hercules Corona Borealis Great Wall. It's a giant flat superstructure about 10 billion light years wide. That's around 10% of the entire observable universe. And it's also a wall. That is, a cluster of galaxies. We were able to detect this giant structure by gamma-ray bursts. It's the brightest electromagnetic event in the universe. You could even see it in the far reaches of our universe. Such bursts are a very rare event. In the Milky Way, for example, it happens once every few million years. If we notice many such bursts in a short time from the same place, it means that there are many objects like the Milky Way in that place. So, there are a lot of galaxies out there. Another unusual giant structure in the universe is the huge, large quasar group. It's about 4 billion light years across. So it takes a photon of light almost as long as our planet has existed just to get from one side of the structure to the other. And if you put the huge, large quasar group on the scale, it would be 6.1 billion times heavier than our Sun. Scientists have found that there are at least 73 quasars in that structure. These are some of the most unusual objects in the universe. They are the active cores of galaxies. At the center of a quasar is a supermassive black hole. This giant eats up the matter around it. A wild force of gravity twists the matter around the black hole, forming a disk. And this disk is the source of the strongest radiation out there. By comparison, the radiation from a single quasar is tens or hundreds of times stronger than that of all the stars in our galaxy put together. Because of such strong radiation, we can detect quasars, even at very long distances. That's why they're also called beacons of the universe. Scientists use quasars to study the universe and the movement within it. One of the most distant quasars from us is about 13.1 billion light years away. This makes it one of the oldest objects in the universe. It appeared about 690 million years after the Big Bang, and it's almost 3 times older than our solar system. It's still glowing with extreme brightness, about 4 and 14 zeros times brighter than the Sun. Scientists explain that at the center of the giant is a supermassive black hole, 800 million times heavier than the Sun. All these giant structures are just building blocks of our universe. Look, this is our solar system. Now, zoom out a little, and this is where our home star is in the Milky Way galaxy. Zoom out again. Here's a local group of galaxies. All the bright spots here are galaxies. Here's Andromeda, and here's the Triangulum galaxy, plus a few dozen other slightly smaller galaxies. They're all gravitationally connected. The size of this structure is about 10 million light years. That's 100 times the width of our galaxy. Zoom out, please. This one is the Virgo supercluster. It's 20 times larger than the local group. There are about 30,000 different galaxies, and the mass of the whole thing is about 1 in 15 zeros solar masses. Zoom out again. Laniakea. This structure is almost 3 times larger. It includes the Virgo supercluster and other smaller clusters. And there are about 100,000 galaxies here. It's not over yet. Zoom out one more time. Here's the Pisces-Cetus supercluster complex. This giant galactic structure contains about 60 clusters of galaxies. So there are more galaxies in it than grains of sand in the desert. You know what to do. Zoom out! Phew, this is the observable universe. There are over 500 billion galaxies. And the stars? Well, there are about 1 billion trillion stars. The observable universe has its own structure. Clusters of galaxies form chains and walls, as you've seen before. But these strands are separated by huge regions of absolute emptiness. These areas are called voids. In these places, there is no matter at all. There are fewer molecules in the voids than in an empty room. One of these voids has a very mystical reputation. It's the Eridanus Supervoid, or the cold spot. It appeared here only 380,000 years after the Big Bang. It's almost 1 billion light-years wide and could hold hundreds or thousands of galaxies with trillions of stars. Some scientists believe that this cold spot may have been the result of the largest collision ever, a collision of universes. There's a theory that our universe is some kind of bubble, a huge sphere that contains all these walls and chains of galaxies. Now imagine that there's an infinite number of these bubbles. They could be parallel worlds or different universes. Many years ago, one bubble came close to the bubble of our universe. Their walls touched, and the two universes connected for a while. It's like two drops of water coming together. But that universe kept moving. The area where the bubbles joined became thinner and thinner until that connection broke, and the two bubbles detached from each other. At this point, the second universe ripped some of the material out of our bubble. All those galaxies that used to fill the Eridanus Supervoid ended up in a parallel universe. Scientists supposed we might travel through other bubbles. Flying to the supposed wall of our universe would take forever, and then it would take even longer to fly through interuniversal space. So we have to use portals, or wormholes. Here's how it works. Imagine a piece of paper with point A on one side and point B on the other. Instead of moving all the way across the sheet of paper, we just fold the sheet so that point A is right above point B. All that's left to do is make a small hole, and the journey takes only moments. Some scientists believe that such shortcuts through universes lie inside black holes. But how do you survive falling into a black hole? You just have to pick one that's big enough. It's all about gravity. Imagine you're falling into a black hole right now. The closer you get to it, the stronger effect it has on you. It intensifies with every inch. At one point, the gravitational force that affects your head is much stronger than the one that affects your feet. Then you turn into spaghetti. Yum. But if you choose a supermassive black hole, like the ones at the centers of galaxies, the gravitational force in them increases gradually. They can be millions of times heavier than the sun and much bigger, but the gravitational force on your head and your feet will be almost equal, and you will still feel comfortable. Who knows? Maybe if you manage to survive a fall into such a massive black hole, you'd find yourself in a completely different universe where different laws of physics apply. But so far, this is just a theory. 13.8 billion years ago, a mysterious explosion happened in space. It was chaos, a time when the stars, planets, asteroids, the rest of the space bodies, and galaxies were born. It was the Big Bang, a theory we all know about. But no one knows for sure what happened, where the universe came from, and what was there before. Some even think the universe went through a cycle where it contracted and expanded several times. In 1991, a cosmologist from Stanford University named Andre Linde had submitted an article with the main idea that there was a possibility the universe had been created in a laboratory. His theory said there was a chance an advanced civilization somewhere out there had created our universe. This civilization has made an entirely new cosmos that later evolved its own planets, stars, and intelligent forms of life. 30 years later, many scientists take this theory pretty seriously. They even started talking about things that we, as a civilization, can do to get to such an advanced level. The theory says this advanced civilization decided to add technology that helped to create a new universe out of nothing. It happened through quantum tunneling. It's when an atom can appear on the opposite side of some barrier, even though it's supposed to be impossible, considering the laws of physics of our world. Like if you wanted to pass a tall wall, but you can't pass it with ladders or go around somewhere. Imagine you can just walk through it like a ghost. In our world, it's not possible, but a more advanced civilization perhaps can do it. Plus, they realized how they could create new universes. Right now, on the cosmic scale, we could be a Class C civilization. We don't know how to recreate some things. For example, conditions on the Earth for when our central star, the Sun, goes out. If we manage to become a Class B civilization, we'll learn to adjust conditions to be independent of the Sun. That means we might be able to learn how to live even without it. And if we level up and become Class A, we'll know how to recreate cosmic conditions and produce our own cosmos in our laboratories. We think of the world we live in through 3 dimensions of space: east-west, north-south, and up-down. There's also 1 dimension of time, which means we can distinguish past from future. A 5th dimension would represent 1 more extra dimension of space. The theory of its existence was first mentioned in the 1920s. It was inspired by the theory of gravity by Albert Einstein, who said space-time is warped by matter and energy. We can't perceive these 4 dimensions, but we see how an object moves and attribute it to gravity. And maybe there's some other force, like the electromagnetic force, that's more than 1,000 times stronger than gravity, that could explain things going on in that extra dimension of space. The 5th dimension is curved in a way we can't see it, but the idea about it was mentioned in a string theory. It considers the universe as really small strings of mass energy, not as particles. They vibrate in 10-dimensional space-time, considering 6 dimensions are rolled up way smaller than a single atom. That led to the picture of the universe as a 3D island that floats in 10-dimensional space-time. Also, the 5th dimension might be an excellent explanation to tell us more about dark matter. That's the invisible stuff with a mass, but we can't see it, nor can it interact with ordinary matter. And dark matter is 85% of all the matter in our universe. The universe can't be still. It's constantly in motion, either contracting or expanding. We used to think there were 100 billion galaxies, but it turns out there are more than 1 trillion. The galaxies are moving away from each other. This is what it means when scientists say the universe is expanding all the time. There are voids between galaxies that sometimes stretch millions and millions of light years across. They can seem empty, but they can also contain way more matter than we can find in galaxies. Still, stars usually can't be formed there because the matter between those areas has lower density. But there's still plenty of so-called intergalactic stars. A good example is the Virgo galaxy cluster, 10% of which are intergalactic stars. We don't know how exactly they got there, but there are 2 possible ways. 1. Stars can collide, merge, or pass close to another galaxy, which can kick it off from its parent galaxy. Option number 2. A supermassive black hole can accelerate a star to very high velocities if they have a close encounter, which can, again, make a star be expelled from its parent galaxy. If you could have a giant magnet, you could even pull something out from the vicinity of a black hole. That's possible if the magnetic field near a supermassive black hole is as strong as the black hole's gravitational field. But it doesn't work if we're talking about material that's already beyond the black hole's event horizon. That's a spot with a gravitational force so powerful, not even light can get away. You'd need to accelerate this material to the speed of light, at least, to get away. For that, you'd need an infinite amount of energy. But a magnet could help if something's heading toward the black hole but didn't get inside yet. When someone mentions a black hole, you might get a picture of some giant void in space. But the Milky Way is most likely full of thousands of smaller black holes that float around the galaxy. When a star comes to its end, it will destroy itself in a supernova explosion, which is a cataclysm of energy. In that explosion, the densities in the core will reach an intense enough state that nothing will be able to escape. At the same time, the major part of the star explodes outward, but a part of it collapses inward, creating a black hole. The bigger the star, the bigger the hole. The black hole then swallows everything that comes in its way, including other stars as well. When a star gets sucked up into the black hole, it's ripped apart because of the strong gravity inside the black hole. Some of its parts fall into the black hole, while others get ejected at incredibly high speeds. Some black holes might have been formed in a different way. The early stages of our universe were, to say the least, pretty chaotic. It had high temperatures and pressures, and was in a state that shaped the entire cosmos. Under the right conditions, any old gas patch may have shrunk itself to become a black hole. And they came in many different sizes, from something that weighs a couple of pounds to giant masses like thousands of suns, and those in between. They aren't really black. Black holes are areas with strong gravity, and no object can escape when it gets inside. They feed off electromagnetic radiation, such as light and space particles. Since they're consuming matter all the time, black holes give off a dark glow. The Earth is not that close to the inhospitable edge of the solar system. We're the 6th planet from it. Scientists made a pretty cool 3D map of our solar system where we can see what the edge looks like. It took them 13 years to design it. The boundary is called the outer heliosphere. It marks the area in space where the solar wind, which is the stream of charged particles our sun emits, gets deflected and draped back by the radiation coming from the empty region beyond our solar system. The inner layer of the heliosphere is where the sun and the planets have a rough shape of a sphere, while the outer layer is not that symmetrical. This asymmetry happens because our sun is moving through the galaxy and goes through friction with the radiation in front of it.
The red parched earth under your feet is shaking. Large cracks are opening in the ground, threatening to swallow you. But unlike on Earth, these quakes aren't coming from within the planet. A threat coming from space is triggering them. Scientists have made a shocking discovery about Mars quakes. By using AI and NASA's InSight data, they found out that some of those tremors are caused by meteorite impacts. It means that Mars gets hit 2.5 times more often than we thought, and new craters are forming all the time. But the scariest part is that these impacts don't just shake the ground. They send powerful shock waves deep into the planet, revealing a hidden seismic highway and an unstable interior, unlike anything we imagined. This changes everything we thought we knew about Mars. So now, the big question is, what else is lurking beneath the surface? But let's follow scientists' train of thought first. They took Marsquake data from NASA's InSight lander and compared it with fresh impact craters spotted by the Mars Reconnaissance Orbiter. That's when they discovered that some impacts create a seismic highway through the mantle instead of being absorbed by the crust. Even though NASA shut down InSight in 2022, its data is still precious. The lander, which placed a seismometer on Mars, recorded over 1,300 Mars quakes, some caused by underground rock cracking under heat and pressure, others, apparently, by meteoroids slamming into the surface of the red planet. By studying how seismic waves move through the crust, mantle, and core, scientists keep piecing together Mars's deep structure. In the past, researchers already linked impact craters with seismic data. But these new studies are the first time when a fresh impact has been connected to quakes detected in Cerberus fossae. That's a highly active region 1,000 miles away from InSight. Scientists have discovered this 71-foot-wide crater much farther from NASA's InSight lander than expected, if we consider the strength of the seismic waves it produced. Mars's crust was thought to absorb most of the energy from impacts, which would limit how far seismic waves could travel. But the analysis of this crater revealed that, instead of getting dampened, the waves took a more direct and deeper path through the planet's mantle. This unexpected finding suggests that Mars has a seismic highway, which allows quakes to spread much farther than previously believed. Now, the InSight team will need to reassess their models of Mars' internal composition and structure. And then, we might better understand how impact-generated seismic signals can reach such depths. Manually sorting through the vast amount of data would have taken years. But luckily, these days, there are new tools, and scientists can go from tens of thousands of images to just a few in a matter of days. So, researchers focused on finding craters within approximately 1,800 miles of InSight's location. Their aim was to identify those that formed while the lander's seismometer was active. By comparing before and after images from the context camera over time, they identified 123 fresh craters to cross-reference with InSight's seismic data. Out of those, 49 craters were potential matches for quakes detected by InSight's seismometer. And after conducting some more analysis, the team decided that the 71-foot Cerberus fossae impact crater was the main finding. This discovery is likely to help scientists differentiate between signals from internal quakes and those caused by meteoroid impacts. Initially, they believed that Cerberus fossae produced a lot of high-frequency seismic signals linked to quakes originating inside Mars. But the new data suggests that some of this activity may have been caused by impacts, not internal processes. Another mystery scientists haven't been able to crack for 50 years is why Mars is split into two very different halves. But thanks to recordings of Mars quakes, they may have finally found the answer. Since the 1970s, researchers have known that Mars has two distinct regions. The northern lowlands cover about 2/3 of the planet's northern hemisphere, and the southern highlands make up the rest. The southern highlands sit about 3 miles higher than the northern lowlands, and the crust, the planet's outer layer, like a shell, is thicker in the south. This strange divide is known as the Martian dichotomy. There are two potential explanations for this imbalance. One theory suggests that an unknown internal process within Mars created the difference. The other claims that a massive collision, probably with a moon-sized space rock or several smaller impacts, once reshaped the planet's surface. But Mars' surface is extremely old. That's why pinpointing exactly what happened has been difficult. But now, a new study, published on December 27, 2024, has used Mars quake data from NASA's InSight lander to figure out whether the cause of this difference lies deep inside the planet. InSight was positioned near the boundary between the northern lowlands and southern highlands. Its mission included recording seismic data from Mars quakes, which travel through the planet's mantle, the rock layer beneath the crust. So scientists compared how these waves moved under both lowlands and highlands. They looked for differences in the planet's deep interior. It turns out that the seismic waves lost energy much faster when traveling through the southern highlands. It means that the mantle beneath this region is significantly hotter than in the north. It's compelling evidence that internal planetary forces, rather than an external impact, caused Mars' unusual split. The research team believes that the temperature difference between Mars' two halves can be traced back to ancient tectonic activity. It once shaped the planet, but later stopped. At some point in the past, Mars had moving tectonic plates, like Earth's. As these plates shifted, they, along with the molten rock beneath them, could have created the Martian dichotomy. But eventually, the movement stopped, leaving behind what scientists call a stagnant lid. That's a thick, immobile layer over the planet's molten interior. If this turns out to be true, it might mean that the mantle beneath the southern highlands is still pushing upward, while the mantle under the northern lowlands is sinking deeper toward the planet's core. This ongoing process could explain why Mars' crust is thicker in the south. At the same time, we can't completely rule out the idea that an external impact created the dichotomy. Some recent studies suggest that a giant collision could still be a possible explanation. To solve this mystery for good, scientists will need more Marsquake data and detailed models of how Mars originally formed. By the way, if you ever decide to visit Mars, you might come across the hero of our video today, the InSight lander itself. It was supposed to launch in March 2016, but a problem with one of its instruments caused a delay. It was a vacuum leak in the seismometer. NASA rescheduled the launch for May 2018, and the issue was fixed in the meantime. But this delay increased the total cost from $675 million to $830 million. Still, InSight successfully landed on Mars on November 26, 2018. But over time, dust built up on its solar panels, making it harder to recharge. The InSight lander runs on solar panels and batteries, but it needs occasional wind gusts, called cleaning events, to clear dust from the panels. Unfortunately, the place where InSight landed didn't get enough of these winds to keep the lander fully powered. By February 2021, during the Martian winter, thick dust had covered the panels, and they were only producing 27% of their full capacity. To save power, NASA started putting InSight into hibernation mode, shutting down instruments gradually to keep its electronics warm. They hoped better weather would allow the lander to recharge and wake up by July 2021. In May 2021, the team found a clever way to restore some power by using the lander's arm to move sand onto the panels, helping the wind clean off some of the dust. But eventually, InSight was only generating 1/10 of the power from the sunlight than it did right upon arrival. In July 2022, NASA put it in low power mode to keep detecting Mars quakes. The lander kept operating until December 2022. On December 20th, NASA announced that InSight had lost contact with Earth on December 15th. and the mission officially ended on December 21, 2022. So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle, it's way thicker. And this is the core. Wait, what's happening here? Uh-oh, the core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with one neutron instead of the usual two. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's central Anatolian plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time, and as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the central Anatolian Plateau has risen for around a half mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the central Anatolian Plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow.
Most of those twinkling dots scattered across the night sky seem unreachable. But one of them is Betelgeuse, a star so enormous and nearby that you can see it with the naked eye. To find it, locate the first 3 big dots in the Orion's belt. A reddish star to the left is Betelgeuse. It's one of the brightest stars we can see from Earth. And it's just 640 light-years away. No big deal. Betelgeuse has a blue-white O-type star, which is one of the hottest types to exist. Betelgeuse was scorching hot, reaching temperatures of about 90,000 degrees Fahrenheit. although that was back in the day. Now it's an elderly star, and it cooled down to just 5,800 degrees. You know, vacation weather. Blue-white stars are absolutely massive and burn incredibly bright because they have loads of hydrogen fuel. But they have a price to pay for this glory. They burn through their fuel super quickly. As they age, they transform into red giants. This is exactly what happened to Betelgeuse. It burned through its hydrogen and started burning helium instead. This caused its outer layers to puff up like a balloon, turning it into a red supergiant and making it one of the largest stars out there. Now it's stretching over 700 million miles in diameter. Now it's about 1,000 times bigger than our Sun. If Betelgeuse replaced it, it would swallow up Mercury, Venus, Earth, Mars, even Jupiter. And its atmosphere would almost reach Saturn. But something strange has been going on. Betelgeuse spinning way faster than it should for a star of its size. Huge stars like Betelgeuse are expected to rotate slowly, but it suddenly started spinning at a rate of about 3 miles per second. Thanks to powerful radio telescopes, Betelgeuse's orange-red surface can be seen in detail. That's how we learned that it often changes its brightness. Sometimes Betelgeuse shines super brightly and then gets very dim. This happens about every 400 days. And recently, a telescope called ALMA, which is made up of many antennas working together as one, showed that Betelgeuse's surface seems to be moving unevenly. It's like one side is coming towards us while the other is moving away. But all of it might be a trick of light. Betelgeuse isn't as smooth as our Sun. Instead, it's super chunky. Its surface is like a boiling cauldron. It's bubbling and churning incredibly fiercely. Imagine giant plumes of hot gas erupting from its core, reaching the surface and then vanishing back inside. And these bubbles are bigger not only than the Sun, but Earth's entire orbit around the Sun. These bubbles also rise and fall super quickly, even faster than a spacecraft. And maybe this tricks our telescopes into seeing it spin faster than it really does. Some astronomers also think that Betelgeuse could have swallowed up another star, and this gave it a spin boost. But these are all just theories. Things got even more complicated when Betelgeuse dimmed once again, this time in a pretty unexpected way. What's interesting, it was discovered using a weather satellite. A regular telescope had a hard time seeing Betelgeuse clearly because of Earth's atmosphere. So they used a satellite that normally watches Earth's weather, but can also take pictures of space. As we mentioned, it usually brightens and dims about every 400 days. But recently, it suddenly dimmed by 2.5 times more than ever before. This event got the name the Great Dimming. The first theory said that Betelgeuse cooled down and sneezed out a bunch of material, creating a massive dust cloud. This cloud blocked the view of the star, making it look much fainter than usual. They also noticed something strange happening to that dust. It started behaving differently, which might be a sign that something deep inside the star was causing trouble. Betelgeuse's brightening and dimming cycle now happens faster in just 200 days instead of 400. And to add to the mystery, in the spring of 2023, it started shining even brighter than it normally does at its peak. Why is this frightening? Because Betelgeuse might be preparing for its grand finale, and this wouldn't be very good for Earth. We might be on the verge of a supernova. When massive stars like Betelgeuse run out of fuel in their cores, they start burning different elements like carbon, oxygen, and silicon. Eventually, they end up with iron in their cores. At that moment, everything changes. Adding helium to iron doesn't produce energy like other reactions do. Instead, it sucks up energy. This causes the star's core to collapse, leading to what's called a core collapse supernova. A spectacular, breathtaking show. Supernovas are so bright that they can outshine entire galaxies. But a Betelgeuse supernova would be special. Because it's relatively close to us, it would be so bright that we could see it even during the day. When it happens, Betelgeuse will shine as brightly as a full moon, but all that light will be concentrated in one point. For about 2 months, it will be so bright that you could read a book just from the light of the supernova, even if you turned off all the city lights and had a clear sky. The idea of witnessing Betelgeuse explode as a supernova is truly thrilling. After all, the last time a star went supernova in our galaxy was way back in the time of Johannes Kepler, more than 4 centuries ago. That event, known as the SN 1604 or Kepler supernova, dazzled the sky for weeks. But don't get too excited yet. We're not sure when exactly it'll happen. One study says that the star might be in its carbon-burning phase. If we're near the end of that stage, then Betelgeuse might blow up very soon, during the next tens of years. But it's nearly impossible to determine because during that last phase, the star barely changes at all. Even though Betelgeuse is close enough for us to study its surface, we can't peek inside its core to see what's really happening with it. We might as well be at the beginning of the carbon-burning phase, and in that case, we might have to wait 1,000 more years before that cool supernova. Another study says that Betelgeuse might have less than 300 years of fuel left in its core. They say that Betelgeuse is known to expand and contract regularly, and its pulsation pattern hints that Betelgeuse is much larger than we previously thought. This would suggest that the star is further along in its life cycle and closer to going supernova. Other guesses come from observations of similar stars. For example, a star called VYCMA in our galaxy is thought to be closer to going supernova than Betelgeuse, and it's been dimming steadily over the past century, unlike the relatively stable Betelgeuse. If Betelgeuse was about to go supernova, it would dim steadily and very quickly. Also, historical records suggest that about 2,000 years ago, people saw Betelgeuse as yellow, not red. If that's the case, then we might be in its early last days after all. In other words, we have no idea whether it will go supernova tomorrow or in 1,000 years. We just gotta wait and see. But let's say it goes supernova tomorrow. What happens to us then? The 1987 supernova in the Large Magellanic Cloud showed that the effects from the supernova might be so strong we can sense it even from very far distances. The Large Magellanic Cloud is almost 170,000 light-years away, and we still detected the radiation. It's kinda hard to say exactly what the danger zone is. A rough estimate could be around 100 light-years. Luckily, Betelgeuse won't pose any danger to humans. It's hundreds of light-years away, and its supernova won't influence us in any way. We'll be able to enjoy its supernova beauty without any harm.
Whoa, a wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is. An asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So, many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kinda like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet, so it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. and we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards.
All the planets of the solar system are slowly lining up. Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Neptune are about to form a straight line. This event, called the Parade of Planets, occurs once every 176 years. The last time this happened was almost 40 years ago, and it was a great chance to explore all these planets in one go. On August 20th, 1977, thousands of people gathered outside NASA's Kennedy Space Center. They came to witness the launch of the most ambitious and distant space mission in history. 5, 4, 3, 2, 1, ignition! Launch rocket Triton took off from Earth and left the atmosphere. As soon as the rocket reached outer space, it launched the probe Voyager 2, which began its journey. The probe consisted of a bus 1.5 feet in height and almost 6 feet wide. On top of it, there was a round 12-foot wide antenna. Most of the scientific equipment was mounted on a boom that extended 8 feet outward. On September 5, 1977, Voyager 1, the identical space probe, left our home planet. It sent us pictures of Earth and the Moon. It soon overtook Voyager 2, launched 2 weeks earlier. That's why the second probe has the number 1 in its name. And so the journey through dark space began. March 5, 1979. About 4 Earth-Sun distances away from our planet, Voyager 1 came close to Jupiter and prepared its scientific equipment to explore the planet. The probe had a dozen gadgets, including a 2-camera system with narrow and wide-angle lenses. So, it could take full-length photos of the planet with the wide-angle camera, as well as close-up photos of specific places on the planet and its satellites. The probe also had a radio science system to determine the atmospheric composition, weight, and gravitational fields of the planets it came across. Infrared and ultraviolet spectrometers could help measure radiation and temperature invisible to the human eye. Various sensors were used to examine cosmic rays. Voyager 1 was the first to find volcanoes outside Earth. Those were on Jupiter's satellite, Io. It has dozens of active volcanoes that constantly spew lava. Then the probe pointed its cameras at the Great Red Spot. That's how people learned that it was a giant cyclone-like storm that hasn't stopped for the entire history of observations of Jupiter. It was also the first time when lightning was detected outside of our home planet. And in the invisible spectrum, Voyager 1 noticed that Io acted like an electrical generator for Jupiter. Ions, which are charged particles, were constantly flying toward the gas giant. This electrical current was 5 million amps. Soon, Voyager 1 continued its journey. 5 months later, Voyager 2 approached Jupiter too. This gas giant has rings around it. They're not like Saturn's though. Jupiter's rings consist mostly of dust. When the planet's rocky satellites collided, they turned into small debris. Gradually, this debris turned into fine dust. Then Voyager 2 approached Europa. This moon is completely covered by a crust of ice, and beneath it, there may be a liquid ocean where life can possibly exist. Voyager 2 was the first to capture the cracks in Europa's ice crust. While flying near Io, Voyager 2 discovered that 6 volcanoes on its surface were still erupting. This meant that the periods of activity of these volcanoes could last for months. Both space probes circled the gas giant several times and then dashed further into space. Such a gravitational maneuver allowed them to gain more speed and saved fuel for the trip. By November 9, 1980, Voyager 1 had already traveled 8 Earth-Sun distances away from home. The space probe arrived at Saturn. It discovered 3 new satellites of the gas giant: Atlas, Prometheus, and Pandora. This proved the theory that these were the moons that kept the planet's rings in line. It also turned out that unlike Jupiter's, Saturn's rings also contained ice. Voyager 1 took a peek at Triton, Saturn's largest satellite. It's 50% larger than the moon and even has an atmosphere. It's the only place in the solar system besides Earth where liquid water has been proven to exist. That's why scientists don't deny the possibility of life there. Then it was time for another gravity maneuver. Voyager 1 once again darted away from the planet's orbit. This time, it was aiming upward relative to the line of the parade of planets. Almost a year later, Voyager 2 arrived there. It made a flyby of several of Saturn's icy satellites. Supposedly, a long time ago, these moons collided and knocked huge chunks of ice and rock out of each other. This debris orbited Saturn, collided, and slowly crumbled into dust, consisting of ice and rock. This is how the famous rings of Saturn were born. Another gravity maneuver, and Voyager 2 set off for the next gas giant. 5 years later, it arrived at its destination, 17 Earth-Sun distances away from our planet. For the first time ever, a human-made object approached Uranus. Voyager 2 discovered 11 new moons there. The probe also found that Uranus was the coldest planet in the solar system. Its temperature is negative 350 degrees Fahrenheit. That's 4 times colder than the temperature at the South Pole. At that time, the Deep Space Network was being tested on Earth for the first time. It's a network of radio telescopes all over the planet. They aim at certain points in the sky to establish communication with extremely distant objects. These telescopes have been successfully receiving signals from Voyagers 1 and 2. August 25, 1989. Voyager 2 had already traveled 23 Earth-Sun distances and arrived at Neptune. It was the first time people received images of this blue planet from such a close distance. The probe discovered 6 new moons there and also took the first pictures of the planet's rings. Engineers then turned off the probe's cameras to save power for its main computer and the instruments that measure the solar and interstellar wind. Voyager 2 left Neptune and headed into deep space. That's why it no longer needed the cameras. A few months later, Voyager 1 sent its last photo back to Earth. It was a family portrait of our entire solar system. Every pale dot was a planet. You can barely recognize Earth in the picture. After that, the camera was turned off to save power. This was the start of the interstellar mission for Voyager 1. For 15 years, Voyager 1 had been flying to the edge of the solar system. On December 16, 2004, the probe passed through the termination shock. This is where the solar wind suddenly slows down and heats up after colliding with the interstellar wind. The space probe managed to endure this test and continued its journey. In 2007, Voyager 2 crossed the same boundary. At that point, sensors recorded a temperature of about 266 degrees Fahrenheit, but the probe managed to withstand it and continued its journey through the dark cosmos. Both Voyagers moved through interstellar space in different directions. They discovered that the heliosphere, the solar wind bubble, is not perfectly round, but more like an egg. August 25, 2012. Voyager 1 became the first human-made object to enter interstellar space. It's now also the most distant artificial object in human history. On November 5, 2018, Voyager 2 also left the solar system. The two probes continued their journey into deep space. Right now, the Voyagers have been operational for 44 years. Voyager 1 has traveled 153 Earth-Sun distances and is moving forward at 38,000 miles per hour. In about 300 years, the probes will reach the Oort cloud. This is a hypothetical region around the solar system with nothing but asteroids and blocks of ice. Scientists believe they might reach the nearest stars in the next 40,000 years. Perhaps one day, the Voyagers will enter these star systems and explore unknown worlds. There may be planets there that look like ours. The probes may even be able to find an intelligent civilization there. For this purpose, each Voyager carries a golden record with a message on it. There are 115 images. Among them, there's our number systems, a map of the solar system and pictures of its planets, diagrams of human DNA, portraits of people, and landscapes from Earth. There's also greetings in 55 of Earth's languages, including the oldest and newest of them. There are also 90 minutes of music from every corner of our planet. The Voyagers also carry a device to play these sounds. If another civilization gets this record, their scientists could decode the data step by step. And then, that civilization may decide to pay us a friendly visit. They'll have to repeat the heroic journey of the Voyagers, though. Dozens of light years through dark space. Then crossing the border of the solar system, and finally flying past Neptune, Uranus, Saturn, Jupiter, Mars, and the asteroid belt toward the little blue planet. We can only hope that people will be advanced enough to welcome them.
This is Earth, 335 million years ago. I wasn't around then, but there's just one supercontinent, Pangaea. See? Let's watch it shift around and fast forward. Okay, here we go. It just split into two huge pieces. Australia goes this way, North and South America go that way. Africa, Asia, Europe, forming, and there we go. The planet as it is today. Let's keep going. I mean, the continents are always on the move. Over time, some of them will crash into each other. Others will break apart. But that'll take about 100 million years. Better put it on super fast forward. 100 years from now, humans keep spitting carbon dioxide into the atmosphere, and the planet's already warmed up a bunch. The world's ocean levels have risen about 4 feet. The Bahamas? They've totally disappeared. 200 years from now, the Earth's population is about 19 billion people. The climate's gotten even warmer. We're packed in like sardines over here. New medical tech makes it possible to live to 180, but why? Fossil fuel reserves of oil and gas, long gone. Oh, and the continents have drifted over 16 feet. The Voyager 1 space probe's about to enter an asteroid cloud at the edge of the solar system. It's the most distant man-made object in the universe, I guess. 1,000 years from now, thanks to better quality food, humans are now 7 feet tall on average. Technology solved the pollution and fuel shortage problem. Humanity's doing just fine. Robots do all the work, we just play around all day. Ocean levels have crept up another 10 feet. Islands like the Seychelles, Maldives, Galapagos, and many others have gone underwater. Denmark, the Netherlands, Eastern England, Thailand, and Vietnam are only partially underwater. There's been a huge human migration these last 100 years. Fast forward about 5,000 more years, and it's the year 8113. Humanity's getting ready to open the crypt of civilization. It's a hermetically sealed room in Georgia, in the States. Bad Georgia. It was created in 1940, and it's full of about 800 books on microfilm, recordings of famous people's voices. It's also filled with bits of technology from that time, like a toaster, a radio, and a typewriter. Some awesome people created the crypt of civilization in case humans experienced a major catastrophe in the distant future and had to rebuild civilization from scratch. We'd all go back to using typewriters. 15,000 years from now, our planet has changed its tilt, and the Sahara Desert is now a tropical paradise. Years of rain turn the dry desert into a wild jungle. 30,000 years from now, the Voyager 1 space probe has finally left the asteroid cloud at the edge of our solar system. If it doesn't collide with anything, it'll be flying in the dark, wide-open outer space for a very long time. 50,000 years from now, the climate's changing a lot. The temperature on Earth is beginning to drop, and we are approaching the beginning of a new ice age. The radio signal with a special "Hello, all you aliens out there" message sent into space in 1974 has reached its destination. The message contained the human number system and data about our DNA and our solar system. If there was someone on the other end to receive this signal, we might have a response from them. 100,000 years from now, one of the largest known stars in our galaxy, Canis Majoris, explodes with enormous force. The explosion of this supernova can be seen from Earth, even during the day, and the nights are much brighter because of the new strong glow in the night sky. What's new on Earth? Supervolcanoes start erupting all over. These volcanoes spew colossal amounts of lava and ash everywhere. Thick black clouds cover most of the sky. This prevents the sun's rays from reaching the ground, and the temperature on our planet drops even lower. Humans mostly live underground anyway, so it's no big deal. Because the stars are gradually moving in different directions, the usual constellations are starting to change shape. Soon, we'll need to come up with totally new constellation names. 250 years from now, a new island's on the map. Back in 2021, it was just an underwater volcano somewhere in the Pacific. After thousands of years of spouting out lava, it finally reached the ocean surface and busted out in the cool, fresh air. Not much growing on it yet. Niagara Falls has long since disappeared, and Lake Erie and Lake Ontario have teamed up to form one huge super lake. 300,000 years from now, the triple star system WR-104 is about to explode. It's spinning crazy fast, and there's a chance that radiation from the explosion could eventually reach Earth. That would do a lot of damage to all life on our planet. Voyager 1 reaches the brightest star in the night sky, Sirius. Not a very funny star at all, it's really Sirius. It's 8.6 light-years from Earth. 500,000 years from now, scientists are pretty sure that a huge meteorite could fall to Earth any day now. It might be even the size of 8 football fields. The impact of such a massive meteorite would cause an explosion so powerful that its sound would be heard on every continent. That would be followed by super strong earthquakes and tsunamis higher than the Brightside Empire municipal building tower thingy. Okay, I just made that up, but who knows what we'll be building in the future. 1 million years from now, the rogue star Gliese 710 comes very close to our solar system. We're surrounded by a huge shield of asteroids called the Oort cloud, and the rogue star is beginning to affect the asteroids hanging out in there. It grabs them, spins them around, and throws them toward the center of our solar system. Comets start to fall on our planet all the time, big ones, causing more tsunamis and earthquakes. 10 million years from now, the Red Sea is gradually expanding into the East African Rift. Africa is now divided in two by a new oceanic gulf. The human DNA molecule has completely decomposed. But it's no big deal. We've become totally digital, without any pesky aging problems. The really cool thing is that other animals have evolved a lot and changed ridiculously. Thanks to a simple interface, we're actually able to talk to dolphins, chimps, dogs, and cats. Turns out cats aren't grumpy, they're just busy contemplating life. 25 million years from now. The San Andreas Fault has been crazy recently and has caused the Gulf of California to flood the Central Valley. There's a new sea on the west coast of North America. 50 million years from now, Africa just collided with Eurasia. The Mediterranean Sea is totally gone. There's a new tallest mountain in the world. Its name? Mount Everest, of course. Australia is continuing its journey north. It already collided with Southeast Asia a few million years ago. The few human colonies still left on Mars need to do some serious packing. Phobos, one of Mars' moons, is beginning to orbit at a lower and lower altitude. That's not good. It's about 14 miles wide, so that's going to be unpleasant. 60 million years from now, the Canadian Rocky Mountains have completely eroded. It's just one gigantic flat plain. 80 million years from now, all that remains of Hawaii is one island. All the others have long since gone underwater. But just next door, a whole new chain of Hawaiian islands has emerged. Finally, 100 million years from now, we made it! The Atlantic's shrinking down to nothing. The Americas are almost rubbing up against Africa. Africa's already merged with Eurasia. We've got ourselves a supercontinent again. Hello, Pangaea Proxima. All traces of human life are gone or buried deep underground. The movement of the continents has destroyed tunnels, roads, buildings, bridges. Animals and plants now reign supreme on Earth. So, where are all the humans? Well, remember we made the jump to digital about 90 million years ago? Things are still going strong. There are trillions of human minds living on a huge hard drive on a spaceship orbiting Earth. The super low space temperature is good for keeping the drive nice and cool. We have millions of different societies, languages, and cultures, just like we had 100 million years ago. The only difference? We're all little ones and zeros in a huge digital universe that we created. And yes, there's still football. Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really, it suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists use these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission: to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky, folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best buy date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fall protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments.
And we have liftoff of the Mars Global Surveyor as America begins its journey back to the Red Planet.
There's a weird structure on Mars, a square. A near-perfect square standing alone in the endless red desert. And it looks too perfect, too precise to be anything but artificial. Nature's chaotic, and it rarely makes things look so deliberate. So the internet took one look at it and lost its mind, as the internet tends to do. The image spread like a virus on social media, igniting every conspiracy theory you can think of. Some were convinced it was proof that intelligent life had once tread upon the Martian sands. Well, let's dive in and sort it out. The image is real, and it's really old. The thing, not the picture. NASA's Mars Orbiter camera snapped it in 2001, capturing a tiny slice of Martian terrain, and there sat the square. Now, is that evidence for intelligent life? Well, Mars is an empty world now, a rust-colored desert. But once, long ago, it may have been something else entirely. A planet filled with roaring rivers, vast oceans, and thick clouds rolling across the sky. Now, in a world like that, life, if it ever had a chance, could have taken root. And there's a possibility it did. Scientists think that life could have existed on Mars in a short period from around 4.1 to 3 billion years ago. It could have started during the early era of Martian history, called the Noachian period, and lasted all the way to the late Hesperian period. Meanwhile, here on Earth, the first oceans were just forming. Life on our planet was just beginning, in the form of tiny bacteria in deep-sea hydrothermal vents. While Mars was already fully wet, on Earth, there were no plants or animals, just microscopic life trying to survive. So, Mars took the lead in the life game. It had a much thicker atmosphere, which could have trapped enough heat to keep water liquid. Valley networks, huge traces across the red landscape, show us the incredible story of rainfall, rivers, and lakes. Huge asteroids were still hitting Mars at the time, and they could have brought organic molecules with them. But if that's true, what happened, and where did life go? A recent NASA study suggests that the answer is more complicated than we thought. Astronomers believe that something drastic happened to Mars, like boom, and its cozy climate was gone, its atmosphere thinned. Without a strong magnetic field like Earth's to protect it, solar radiation stripped away the air, leaving Mars cold and dry. The ocean simply evaporated. Some of the water escaped into space, while the rest froze underground or became locked in polar ice caps. Today, all that remains is a ghostly memory, dry channels and salty mineral deposits. But it looks like the transition wasn't sudden at all. It was slow and gradual. The planet was changing from wet and warm to cold and dry over millions of years. In fact, Mars kept its ocean even after the temperatures dropped to freezing. Some parts of Mars, especially the northern lowlands, might have remained wet for many, many centuries. Shouldn't the water freeze when it gets below 32 degrees Fahrenheit? Well, yeah. But there are many reasons why this miracle happened, like Mars's thick atmosphere and warm water traveling through currents. And during that time we mentioned before, from Noachian to the late Hesperian, life could have found a way. Microbes on Earth thrive in some of the harshest places, beneath Antarctic ice, in deep sea vents, in toxic volcanic lakes. Hey, life doesn't care. So these times in Martian history would be amazing for it. But don't be mistaken, Mars was never a paradise. Even during its cozy times, it wasn't as lush and green as we might imagine. In its early days, Mars was something more extreme, something closer to the young Earth. During the Noachian period, it was warm yet wet. Then, the climate shifted into the Hesperian period. Oceans were stretching across the northern lowlands. Temperatures dropped, and snow piled high, forming massive glaciers in the south, transforming the planet into an icy world. Finding microscopic life at that time is possible, but an intelligent civilization? That's less likely. The square that went viral isn't evidence for intelligent life yet, and here's why. First things first, people freak out because nature doesn't make straight lines. But that's not really true. Actually, nature does it all the time. For example, here on Earth, we have the Giant's Causeway in Northern Ireland, a beautiful field of hexagonal basalt columns. These are completely natural. They're formed by volcanic activity. There's also the Devil's Tower in Wyoming. Hey, remember it from the Close Encounters movie in the 80s? That's a symmetrical rock formation, and it was created by erosion. However, if we looked at these things from space, they'd look artificial. So, what is the square? How about a fracture pattern in the rock or some terrain that's broken apart along straight lines due to stress? This happens on Earth all the time when rock expands and contracts over time. And on Mars, the surface is just constantly battered by meteors, winds, and extreme temperature shifts. No wonder rock would get stressed. What happens here is another case of pareidolia. It's our brain's favorite thing, to spot patterns in something random. Hey, we evolved like this. So sometimes we might look at natural objects and see insane stuff. Faces on trees, animals in clouds, shapes, and so on. Besides, NASA has been photographing Mars for decades. We have high-resolution images of craters, mountains, valleys, riverbeds, everything. Wouldn't an ancient civilization leave us, well, something better than some square-like rock? Even though things erode over time, we'd find more signs, roads, foundations, artifacts, ruins, or at least something. Though, to be fair, we do see something. The square wouldn't be the first time Mars has played tricks on us. Over the years, we've spotted everything, from tunnels to carved faces, even Bigfoot. Or this doorway, for example, a perfectly cut rectangular opening. That's what people saw when NASA's Curiosity rover sent back an image of the East Cliffs on Mount Sharp. It's almost like an ancient passage leading deep into the surface. You just need to go in and find some fantastic underground base. Well, NASA decided to take a closer look at it. It turns out it's just 12 inches tall and 16 inches wide, the size of a dog door. That's because what we're looking at isn't a doorway, but an open fracture, a break in the rock that happens naturally over time. These kinds of cracks are extremely common, both on Earth and on Mars. They form when bedrock is stressed, expands, contracts, or gets eroded by wind and time. If you walk through a desert here on Earth, you'd see plenty of similar shapes. Canyons, cliffs, and even boulders have fractures that, from the right angle, might look like doorways. They're just not getting photographed by NASA. Also, the straightness of lines turns out to be just a trick of perspective. If you zoom out, you'll see that it's just one small break in a much bigger rock formation. Or the infamous Cydonia face. The photo was taken back in 1976 by NASA's Viking 1 orbiter when it was scanning Mars. In the region known as Cydonia, it captured what looked like a massive humanoid face, a rocky formation about 1.2 miles long. And this one face inspired books, documentaries, movies, and podcasts. But when NASA's Viking orbiters first took pictures of Cydonia, the cameras weren't super advanced. The image of the face had a low resolution and made the details fuzzy. NASA's later missions had far better cameras, and when Mars Global Surveyor revisited Cydonia in 2001, the truth was undeniable. The face was just a hill. a lumpy rock formation with ridges and depressions carved by wind and erosion. And in 2006, during another mission, a colored image with insanely high detail was made. No traces of face left there whatsoever. That's another pareidolia trick for you. Now, Mars has plenty of secrets left to uncover, but they will be related to its fascinating history, not some secret ancient civilization. The conclusion is, don't trust everything you see online. Sometimes a mysterious rock is just a rock. On August 20th, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped it would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna. It allowed the spaceship to send the data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spaceship to study all 4 giant planets from up close. It was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot. That's a colossal spinning storm in the planet's southern hemisphere. The storm is the size of Earth and moves at a speed of 1,500 miles per hour. These winds are the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system. Those were Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space. These objects easily overcome Earth's gravity. But the Sun is around 300,000 times as massive as our home planet. That's why its gravitational pull is way more difficult to fight. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere. That's a bubble of magnetic fields and particles produced by the Sun and protecting the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, some of the largest of Jupiter's moons. Then the space mission passed by the gas giant itself. The distance between the spacecraft and the planet was around 400,000 miles. That's when the probe noticed some changes in the shape and color of the Great Red Spot. It's an enormous, long-lived storm system, like a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn. It discovered spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and up past the gas giant, it passed through the plane of Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust. This kept shifting the probe's direction, and its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low power to save energy. In August 2007, the spacecraft passed the terminal shock. It's the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. In the summer of 2013, the probe reached interstellar space. Now, when it comes to sending and receiving signals in space, there are 3 factors you should keep in mind: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. And when it finally gets there, it's extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Plus, such spaceships as Voyager 2 are powered by radioactive fuel. When special material radioactively decays, it releases heat that gets converted into electricity. Unfortunately, the more material decays away, the less power the spacecraft has for receiving and transmitting radio signals. Despite this issue, we haven't lost the connection with Voyager 1 and 2. That's because new and more powerful technologies appear on Earth. Signals people send can reach much farther than before. That's why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spaceship was switched off. After the communication with the spacecraft stopped, NASA spent around 11 months upgrading its deep space network and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that can reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received a lot of repairs and upgrades, but these 11 months were the longest the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operators sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal. The probe confirmed it had heard the call. After that, the spacecraft carried out the commands. While the dish was offline, the mission operators could actually receive scientific data and health updates from Voyager 2. Astronomers kept getting data from interstellar space, the region outside the Sun's heliosphere, but they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and it was done just in time. One of the transmitters, that was used to communicate with Voyager 2, hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They're spaced equally around the globe. This way, almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon. It was the only close encounter people had with the 8th planet of the solar system and its moon. By the way, Triton is the largest known object that is believed to be born in the Kuiper Belt. That's a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny inner moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. Anyway, to make this detour, Voyager 2 had to travel over the gas giant's North Pole. But this changed the probe's trajectory, deflecting it southward relative to the planes of the planets. Since then, Voyager 2 has been moving in that direction. And now, the spacecraft is so far away that it's out of reach of the radio antennas in the Northern Hemisphere, those in Madrid and California. This makes DSS-43, which is located in the Southern Hemisphere, the only dish powerful enough in broadcasting just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory. After passing by Saturn, it took a different path. That's why now it can easily communicate with the 2 facilities in the Northern Hemisphere. The upgrade the Canberra Deep Space Communication Complex has gone through can also benefit other space missions. For example, the Mars Perseverance rover that landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon.
Jupiter has 79 known moons, and the 4 biggest of them that are particularly interesting are Galilean moons. They were named after Galileo Galilei. He discovered them in the 17th century. They have something in common, but at the same time are all very different. Europa is the smallest of the Galilean moons with a diameter of 1,860 miles. It orbits Jupiter every 3.5 days. The first images we got from there were taken in the 1970s. Its surface mostly consists of water ice. Europa has long fractures, often around a mile wide, that can extend for thousands of miles across its surface. They were probably formed as the crust pulled apart from tidal forces on the mysterious ocean beneath the surface. In 2012, scientists discovered water vapor plumes erupting close to its south pole, rising up to 125 miles. These plumes can help us find what's inside Europa without having to land there. Scientists think there could be a magnificent ocean hidden 10 to 15 miles beneath the solid surface. That ocean could be 40 to 100 miles deep. Even though it's just 1/4 of Earth's diameter, it contains twice as much water as all of our oceans together. This ocean is a potential environment for some forms of life. Scientists believe the entire ice crust is floating on that ocean. It probably makes a full rotation around Europa once every 12,000 years. In the image the Galileo spacecraft took, you can see small dark brown spots. They're 6 miles across and formed as the hot, less dense material was getting to the surface. It either pushed the crust or broke through it altogether. The surface of Europa consists of so-called chaos terrains. They're rough areas surrounded by a smoother surface. Its equator could be covered in ice spikes called penitentes that can go up to 50 feet high. We have them on Earth too, especially in dry areas at high altitudes. But none of them are as big as those on Europa. Our moon has over 5,000 big craters with a diameter of more than 15 miles. Europa's surface lacks impact craters and doesn't look like it's more than 50 million years old. This means the surface of Europa is changing and reforming all the time. This moon is icy and is one of the smoothest of any solid space objects in our solar system. Because of it, it's 5 times brighter than our moon. Europa is under a constant blast of radiation coming from Jupiter. It's so strong, we wouldn't last even a day there. Europa is 5 times further away from the center of our solar system than Earth. That means it barely gets any heat coming from the sun, so it can remain frozen since the average temperature is negative 250 degrees Fahrenheit at the equator and around negative 360 degrees Fahrenheit at the poles. About 40 years ago, the Voyager 1 spacecraft came close to the rocky moon Io and discovered that it's a volcanic champion of our solar system. Io is Jupiter's 5th innermost moon, 4.5 billion years old, nearly the same age as Jupiter itself. It's similar in size to our moon, and even has a similar density and amount of gravity. Many moons in our solar system consist of silicates and water ice, but Io is made of iron and silicate rock. You'd be able to see some beautiful auroras on Io. As this moon rotates around Jupiter, auroras change brightness all the time, but they're always there. Io is relatively close to Jupiter, almost 260,000 miles above its cloud tops. If you could come to Io and take a look at Jupiter from there, it would appear almost 40 times bigger in the sky than our moon. Stargazing there would be amazing. Io needs 42.5 hours to orbit Jupiter. Our moon needs almost a month. At some points, Io's tidal bulge can go up to 330 feet. It's similar to what we have on Earth. The gravity of our moon causes ocean tides. Io doesn't have an ocean, but the ground itself moves and goes up and down. It's like an elevator taking you to the bottom and then the top of a building with 30 stories. The gravity of Jupiter and its other big moons affect Io, so the solid ground tides on its surface are over 5 times as high as the highest ocean tides on our planet. All this makes Io so hot on the inside that some of the inner materials melt, boil, and try to escape in any way possible. Eventually, it creates a hole in the ground, which then turns into a volcano. Io is the most active body in our solar system when it comes to volcanoes. Io has more than 400 of those, with 150 of them erupting all the time. Some of them shoot their hot gas plumes 200 miles into space. It would be difficult to walk there because we're talking about a pretty intense world of floodplains of liquid rock, huge lava flows, multiple lava lakes, and giant collapsing mountains. Ganymede, the largest moon in the solar system we know of, also has the biggest water ocean. It's 26% greater than Mercury when it comes to volume, but it's less dense. This giant moon has a thick crust of water ice 90 miles deep. There might be a huge ocean of liquid water underneath. It extends 60 miles deep, which is about 10 times deeper than the deepest point in the Earth's ocean. The Voyager spacecraft also detected polar caps made of water frost there. Ganymede is half rock, half water, including tiny amounts of metals and ice. Its atmosphere is very thin and doesn't contain oxygen. This ocean most likely doesn't contain life. The Earth is a great example of how certain microbes and creatures can survive deep down without sunlight. But the ocean of Ganymede is so deep and the pressure is so strong that the water at the bottom is probably compressed back into ice. Certain forms of life in the deepest areas of our ocean survive thanks to geothermal vents that eject minerals. Since there's likely thick ice between the ocean and the core, this isn't the case with Ganymede. But the ocean there is salty, with multiple layers divided by icy sheets. If there's any chance of life, it could be in the part where the rocky core is in contact with the most internal icy layer. Beneath all that water and ice, Ganymede is the only moon in the entire solar system with a magnetic field. It's possible because this moon has a liquid core. Ganymede circles Jupiter approximately once every 7 days. Its orbit is so eccentric that at some points, it's pretty close to Jupiter. Ganymede, Io, and Europa have gravitational forces that affect each other. In the time Ganymede orbits Jupiter once, Europa makes 2 orbits, and Io makes a full circle 4 times. 1/3 of Ganymede's surface contains big dark regions, while the other 2/3 are lighter. Dark areas are older and contain more craters. Lighter areas have long ridges and grooves, about 2,300 feet high and thousands of miles long. Callisto, the third biggest moon in the solar system, 3,000 miles in diameter, needs 17 Earth days to orbit Jupiter. Its atmosphere is very thin. There are many impact craters, but its ancient crust has basically been the same for more than 4 billion years. When a planet is geologically active, like the Earth, some things can erase most of the evidence from past impacts: water, volcanoes, tectonic plate movements, human activity, and weather. All this changes the surface. Callisto has experienced none of those. Scientists think this moon used to be an ocean world that eventually froze over. It was hit by meteors from time to time, but mainly remained untouched. And yet, it still has some pretty impressive craters, like Valhalla, the biggest multi-ring crater in our solar system. That's 2,500 miles in diameter. Major craters on Callisto contain more rings than those on other celestial bodies. Whatever hit the moon was big enough to have punctured the thin crust, causing water to spread on the surface. And under this thin crust, there could be either salty ocean or soft ice. The Galileo space probe detected that Jupiter's magnetic field couldn't penetrate through this moon, likely because of a layer at least 6 miles thick. That's why it's hard to explore Callisto. Moons like Europa have vents that eject water from the subsurface oceans. But to explore Callisto and discover more about its past, we'd have to use the old-school way, digging through the crust. If we wanted to explore the outer parts of our solar system, Callisto would be a great spot because Jupiter's radiation doesn't reach it. So we'd be safer there than on some other inner moons. Black holes tearing apart enormous stars, pulsars spinning at incredible speeds and emitting powerful beams of energy, colorful nebulae with fireworks of newborn stars, galaxies of every possible color and size. All of these are found within our universe, but it's not infinite. It has a boundary, a literal wall, and beyond that, there's an absolute nothingness. Right now, we're going to make a journey to that wall. But first things first, our universe is like a humongous nesting doll. If you open it up, there's a smaller one inside. It's a galaxy. Inside that is an even smaller doll. That's our solar system. And the smallest doll of all is the Earth. Each of these dolls has boundaries that we're going to cross. For that, we'll need a spaceship, and a big one. It also has to be able to move 100 times faster than the speed of light. You get on board and start the engines. 62 miles above sea level is our first boundary. That's 10 times higher than passenger planes fly. This point is called the Kármán line. It separates the atmosphere of the Earth from outer space. Now we fly further to the edge of our solar system. We turn on the hyperdrives and fly past Mars, Jupiter, Saturn, Uranus, and Neptune. We've traveled a distance of 100 astronomical units. 1 AU is the distance from Earth to the Sun. And here's the boundary of our solar system, the heliosphere. Here, the speed of the solar wind decreases rapidly. First, it drops from 620,000 miles per hour to the speed of sound. Then, there's a layer called the heliopause. This is where the wind almost vanishes. And then, our ship experiences a bow wave. This is where we feel the force of the interstellar wind, which collides with the boundary of our solar system. When you pass this boundary, you find yourself in the dark of interstellar space. And here, you can find 2 human-made objects that made this trip for the first time in history. They're Voyager 1 and Voyager 2. Voyager 1 crossed that boundary in 2004. Voyager 2 did it in 2007. These space probes discovered that the heliosphere is not a perfect ball around the Sun. Its southern boundary is 10 AUs closer to the star than the northern one. So, we're moving in interstellar space and will soon approach a stone wall around our solar system. 200,000 AUs further, and there it is. This wall of rock is the Oort cloud. In fact, it's a pile of asteroids that surround our world. Scientists speculate that the Oort cloud could be the source of comets and meteorites that fall to Earth, but they're so sparse that we easily fly between them. Now we're in complete darkness. The Milky Way is about 106,000 light-years wide. In a conventional rocket, it would take billions of years to fly across that distance. But you throttle to the max. You masterfully fly past the stars and planets as if on a racetrack. And within minutes, you're at the edge of our galaxy. There's no more interstellar wind. All you see are bright dots somewhere in the distance. These dots are huge galaxies. We need to look at a map to make a route to the edge of our entire universe. You're here, near the Milky Way galaxy. It's part of a cluster of galaxies called the Laniakea supercluster. But even this huge thing is like a little street in a big city. Zooming out, we find Hydra Centaurus supercluster. Thousands of galaxies on the map look like little dots. Maximum zoom out. This is our entire observable universe. We thought it was infinite, but we may have proof that it has a boundary. It's here, 10 billion light-years away from our home. Even if you travel at the speed of light, a trip there would take twice as long as our whole planet has existed. During that time, the sun will either fade away or explode like a supernova, destroying our entire solar system. And if you can live that long and then return home, you will see that our galaxy is there no more. It's long since collided with the Andromeda galaxy and merged into one big cosmic body. Luckily, your ship is able to warp space-time so that this journey will literally take a few seconds. Boom! Congratulations! You've arrived at your destination, the Eridanus Supervoid. Some scientists believe this location is the evidence of collisions of our universe with something big enough to leave such a large scar. The Eridanus Supervoid is an empty and cold space 1 billion light-years wide. If you think of this void as a cup, it would fit at least 10,000 galaxies, and it appeared after an accident of gigantic proportions. The object that crashed into our universe was another universe. Yes, other universes may actually exist. Imagine that our entire universe is a huge bubble that contains all the clusters of galaxies in the observable universe. There could be an infinite number of such bubbles. They could have been born during the Big Bang. These universes may be different from ours. They may have other galaxies and nebulae. But these bubbles could also be parallel universes. This means that if you chose cereal over oatmeal in the morning, In another universe, your twin would choose the oatmeal. Every choice you ever made in life had completely different consequences in a parallel universe. And because the number of choices are infinite, there's a whole infinity of parallel universes. So, like a regular bubble, our universe has a wall that is near the Eridanus Supervoid. Long ago, another bubble flew past ours. As they approached each other, their gravitational fields began to interact. Our boundary wall began to deform and pull toward the other universe. The same thing happened on the other side. Then the walls of our universes came into contact. But as these bubbles moved, their connection began to break, and the other universe just ripped a huge chunk of ours. A cold void was formed at the point of collision, and that was the Eridanus Supervoid. The problem is that the universe looks the same to the observer, regardless of point of view. For example, imagine a basketball hanging in the air. Now, if we put an ant on the ball and tell it to find the edge of the ball, it will start running around it, making an infinite number of circles. But the landscape around the ant will not change. All it will see is a rounded horizon. That's because the ball remains the same from any point of view. The same thing happens to us when we try to find the edge of our universe, all because we imagine the world in three-dimensional space, and our view is limited. For example, you see an ordinary square in two-dimensional space, but if you add depth and change the point of view, voila, it's a cube. If we could see the universe in four-dimensional space, a square might be something completely different. But maybe we can leave our home bubble. The key to traveling to another universe might be inside a black hole. A black hole is one of the most mysterious objects in the universe. They're so heavy, they warp not only space, but time as well. It's like putting a heavy boulder on a net. The net will sag, and the closer you get to the boulder, the stronger the curvature is. Once you're in the gravitational field of a black hole, you can't leave it. We still don't know what might actually be in the heart of a black hole. Some scientists speculate that white holes also exist. Theoretically, they should be born along with black holes. Except for the color, they're the exact opposite of black holes. Nothing can come close to a white hole. At the moment, there's no data on such objects, but general relativity theory suggests they do exist. There's also a theory that a black hole may be a passage to another universe. When you get into a black hole, you can come out the other side through the event horizon of the white hole. So you bypass the boundary of the universes and find yourself in a completely different world. But we may have proof that a white hole exists. In 2006, scientists discovered an unusual burst of energy somewhere 1.6 billion light-years away from Earth. This burst was unique. It didn't look like a supernova explosion or even the merger of two black holes. Some astronomers believe it was the birth of a white hole. But because it was unstable, it was destroyed almost immediately. This process was reminiscent of the birth of our entire universe, the Big Bang. So, scientists called it the Little Bang.
We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, and these signals aren't anything new. They'd been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there, yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny superdense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, It gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with the magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them.
The space crew had been getting ready for the launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours, and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the moon on July 20th, 1969. Since then, the moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the moon. So, the Lunar Year 1, Day 1, began on July 21st, 1969 at 2:56:15 Universal Time. Since the moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the moon's poles, however, the temperature is always at around minus 400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the moon's existence influences us so. In the Middle Ages, scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions. Because they saw this inexplicable connection to the full moon, people with these symptoms were named lunatics, or at times, literally, moonsick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture. But scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our moon, and is called the South Pole Aitken. This giant formation is located on the far side of the moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the moon. Is something strange happening with our moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color depending on various phenomena. The moon seen near the horizon will most likely be yellow or red-tinted. The rarer, blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, but what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project for example, scientists need to take this into consideration, not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission scheduled for May 2024. Artemis 3, 4, and 5 are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days.
Our universe is like a giant highway, and galaxies are constantly moving along this highway. And just like cars driven by careless drivers, they can collide and crash. So, astronomers have recently witnessed such an incredible cosmic collision. It involved galaxies traveling at incredible speeds. Using advanced instruments, researchers clocked one galaxy traveling at a speed of around 2 million miles per hour as it crashed into a group of other galaxies. This collision has created shock waves that are so powerful they can completely reshape the entire region, leaving long-lasting effects on its structure and dynamics. Will it somehow influence our solar system? Before we find out, let's learn more about the region where this collision occurred. Actually, this collision is still happening in Stephan's quintet. That's a fascinating cluster of galaxies that has been the subject of study for scientists for over a century. It's a group of 5 galaxies located in the constellation Pegasus. This group of galaxies was first discovered in 1877 by the French astronomer Édouard Stephan, who used a telescope at the Marseille Observatory. Despite its tranquil name, Stephan's quintet is anything but peaceful. It's a chaotic spot filled with galactic collisions and turbulence. 4 out of the 5 galaxies are gravitationally bound. It means they are physically interacting with one another. Such interactions are ejecting material from the galaxies, and over time, it forms vast debris fields in the space surrounding the galaxies. Astronomers believe that, in the end, these galaxies will merge into one giant galaxy, but it will only happen in millions of years. The curious thing, though, is that the 5th galaxy in the quintet, located in the upper left corner of images, is not part of the collision. This galaxy is much closer to Earth, more than 200 million light-years closer, to be precise. So its alignment with the other galaxies is just a chance perspective from our vantage point, making it appear as part of the group. Stephan couldn't know this in the 19th century, so the name quintet has remained, even though only 4 galaxies are physically involved in the collision. Now, how about we look at this collision in detail? At the center of this event is one of the galaxies in the group, which is currently crashing into the others at a breathtaking speed. From our perspective on Earth, this galaxy appears to be approaching the quintet from behind, heading directly toward the viewer. The collision is creating a massive shock wave that ripples through the surrounding galaxies. As the shock wave is moving through packets of cold gas, it's traveling at hypersonic speeds, several times the speed of sound in the intergalactic medium. This process strips electrons from atoms, leaving behind long trails of glowing ionized gas. But when the shockwave comes across regions of hot gas, it compresses the material rather than disrupting it. This compression produces radio waves, which can be detected by radio telescopes. While reshaping the structure of the intergalactic medium in Stephan's quintet, this shockwave also influences the future evolution of the galaxies involved. Now, how did scientists even manage to spot such a dramatic space event? All thanks to innovative technologies. The most important participant was WEAVE, a cutting-edge spectrograph that's installed on the William Herschel telescope in La Palma, Spain. This tool specializes in gathering spectroscopic data, which is the information about how matter absorbs or sends out light and radiation. It allows astronomers to examine the movement and composition of space objects with great precision. Besides WEAVE, researchers have used data received from a few other large observatories. One of those was LOFAR, Low Frequency Array. It's a radio telescope with an antenna network observing the radio waves the weaker shockwave produced while compressing hot gas. Astronomers combined the data received from all these instruments and managed to study the shockwaves and their effects in amazing detail. This collision in Stephan's quintet gives us a fantastic opportunity to find out more about the interactions between galaxies, which can influence the evolution of the universe. You see, when galaxies crash into each other, their gas and dust gets redistributed, and it can trigger the formation of new stars and even cause central supermassive black holes to grow. And if we talk about Stephan's quintet, the ongoing collision in this area helps us get additional information about the behavior of gas under extreme conditions. Now, at the same time, galactic collisions aren't as rare as you might think. They're common on a cosmic scale, and in the early universe, collisions occurred even more frequently because galaxies were located much closer together. With time, such interactions have played a key role in shaping the universe. Even our own galaxy, the Milky Way, has experienced tons of past collisions. We can see the evidence of such destructive interactions in the form of debris streams and disrupted star clusters within the galaxy. In fact, astronomers predict that the Milky Way will collide with the neighboring Andromeda galaxy in about 4.5 billion years, eventually forming a new, larger galaxy. Even though they're moving at incredible speeds, galactic collisions are super slow processes from our human point of view. While galaxies may travel at millions of miles per hour, the distances they cover are so vast that mergers take millions to billions of years to complete. Now, galactic collisions don't look like explosive crashes you might be imagining. Instead, they resemble when fluid merges. When two galaxies collide, their gravitational forces distort their shapes. They stretch and warp, and exchange their material, stars, gas, and dust. As a result, tidal tails, rings, and even bridges between galaxies form. One of the most famous collisions between galaxies is ARP-148. During this cosmic crash, one galaxy became shaped like a ring, while the other stretched in a long tail-like form. That's how powerful gravitational interactions between galaxies during collisions are. But however impressive intergalactic collisions are, collisions between neutron stars, those ultra-dense remnants of massive stars, are among the most energetic phenomena in the universe. Neutron stars are incredibly small and dense. Just one contains the mass of our Sun packed into an area the size of a city. When two neutron stars collide, they often merge to form a black hole, releasing immense amounts of energy in the process. These events produce gravitational waves, ripples in space-time, that can be detected by instruments like LIGO and Virgo, as well as bursts of light that outshine billions of stars. On Earth, the possibility of a galactic collision directly affecting us is extremely low. Luckily, the timescales and distances involved make such events harmless to life on our planet. However, smaller-scale collisions, such as an asteroid impact, are more plausible. Asteroid impacts have occurred in Earth's history, and the most infamous of them caused the extinction of the dinosaurs 66 million years ago. And while large impacts are rare, astronomers closely monitor near-Earth objects to protect our planet from potential threats. Now, while we're talking about space collisions, a question may arise. Can life travel between planets? This is the idea of lithopanspermia, the transfer of life between planets via debris from collisions. If an asteroid or comet hits a planet, fragments of rock could be ejected into space. If those fragments carry microbial life, they might land on another planet and seed life there. And guess what? According to experiments, certain super tough microorganisms like cyanobacteria could survive the harsh conditions of space travel, including radiation and re-entry into the atmosphere of another planet. In any case, lithopanspermia is still only a theory and a controversial one among scientists, but it doesn't make it less fascinating. It might eventually help us understand how life could have spread across the universe. But let's return to the ongoing collision in Stefan's quintet. By studying such events, astronomers learn more about how galaxies interact, evolve, and influence their surroundings. Hopefully soon, we'll find even more interesting facts about this process. Stay tuned. Imagine if somewhere, trillions of light years away from our world, there's another version of you watching this very video right now. Not as crazy as it might sound. The multiverse theory is having its time of the day, from Marvel's movies to Spider-Verses to the recent famous hit Everything Everywhere All at Once. But it's not just some wild sci-fi concept. Physicists have been talking about this theory for decades. Let's see what they say. Do parallel worlds exist? If they do, let's hope that this is the reality where you click that subscribe button before diving into the video. Now, everything starts with the Big Bang. Before the Big Bang, the universe, with everything we know, was crammed into an unbelievably tiny, super hot, and mega-dense point. Our universe is about to burst into existence. And then, boom! The most colossal event you can imagine happens. In an instant, this tiny point expands with indescribable speed. It's the beginning of everything – time, space, and all the galaxies that surround us. Then, like an extremely hot balloon, the universe started stretching out in all directions, which sounds logical, but what's curious is that this inflationary epoch lasted for an incredibly brief time, in less than a blink of an eye. It's like the universe hit the fast-forward button and then everything eventually slowing down over time. After this speedy phase, the universe kept growing, but at a more normal pace. This rapid expansion is called inflationary cosmology. It explains some big mysteries about our world. It tells us why it looks the same in all directions, why the background radiation is evenly spread, why galaxies are where they are, and so on. The details of how this cosmic inflation works are still a bit mysterious, but scientists are on it, and the theory itself is universally accepted. But it wasn't always this way. To scientists, this idea sounded like insane sci-fi at first. However, it explains so many things that the scientists just had no choice but pay attention to it. However, its initial weirdness was just the beginning. Now, according to this theory, inflation might not be a one-time thing. It could be happening repeatedly, maybe even endlessly. Picture the universe as a never-ending cycle, with each burst of inflation creating its own bubble universe. And the most important thing is that these bubble universes might not play by the same rules. Some could be totally weird, where the laws of physics are going crazy in ways we can't even fathom. Which means there might be a whole constellation of bubble universes out there. However, we can't directly see these other bubbles. They exist beyond the edge of our spotlight. That's where the multiverse theory comes into play. People have been chatting about the idea of multiple universes for a long time, like way back in ancient Greece. Now, back in the 1990s, people got really interested in this idea, and this concept started popping up in books and movies. As a result, scientists began talking about it increasingly in scientific discussions and journal articles. And nowadays, many scientists and philosophers are into it. Now, the problem is, there's no solid proof or evidence that these other universes really exist. It's not a proved or confirmed theory. It's not even a theory at all, just a hypothesis, a bunch of interesting thoughts put together. Before we draw any conclusions, we need much more in the way of clues and evidence, and unfortunately, it's hard to find the evidence of parallel worlds when we can't live or look past our own, which is why many scientists believe that it might not be real. But not everybody agrees with that. While critics say that we can't observe the multiverse and therefore can't test it, some physicists suggest a different approach. Instead of trying to find these parallel worlds, we could try to look at ours and its history. Around the 2010s, researchers took a closer look at data from a space gadget called the Wilkinson Microwave Anisotropy Probe. Yes, that's a mouthful. They thought they found signs suggesting that our universe might have bumped into other universes in the past, like sort of a collision. But then scientists used an even fancier satellite, which had 3 times better resolution, looked at the data more thoroughly, and didn't find any strong proof of these universe collisions. Plus, there was no evidence that other universes were tugging on ours with their gravity. However, an interesting discovery happened in 2015. One scientist checked out radiation left over from the Big Bang. He claimed to see something super bright, 4,500 times brighter than expected. Well, at least based on the stuff, like protons and electrons, scientists think existed in the early universe. So he and some others assumed that this might be our first evidence of our universe crashing into others. But let's assume that it does exist. The multiverse wouldn't be about human decisions creating alternate timelines. In quantum mechanics, it's not human decisions that split everything into parallel worlds, but the measurement of subatomic particles. So if we look at this theory scientifically, other worlds would be billions of light years away, and what's happening to them wouldn't have anything to do with our daily choices. So what would it look like? Well, Max Tegmark, for example, talks about 4 levels of universes and multiverses. Level 1 is the extension of our world. Our universe is a big place, and in an infinite universe, there would be infinite chunks like ours, each with its own story. Most of these chunks might look different from ours, but because there are so many, some might look just like ours, but they'd be really, really far away. Level 2 is a universe with different physical constants. This idea says that our universe is part of a much bigger space where bubbles form. Each bubble might have its own set of rules, like different laws of physics. Level 3 is the many worlds interpretation of quantum mechanics. This one's a bit tricky. In the quantum world, things can be weird. Imagine rolling a dice. Each number that comes up might create a separate universe. So if you rolled a dice and got a 3, in another universe, it would be a 6, and so on. Yeah, my head's spinning. This idea suggests that every possible outcome in quantum events creates a whole new universe. And level 4 is the ultimate ensemble. This level gets super abstract. It says that everything, every possible universe or reality, can be described using math. I wish now I hadn't fallen asleep in algebra. Imagine all the different math equations describing every conceivable way the universe could be. This level says that every math equation that can describe a universe actually exists, and they're all real in their own way. Stephen Hawking was a proponent of the Level 3 many worlds interpretation. It was one of his last theories before he passed away. He predicted that the universe is finite and far simpler than many current theories about the Big Bang say. According to Hawking, the universe is like a giant quantum system, a sea of possibilities and probabilities. In this view, every outcome of the universe's history plays out in parallel existences, and we, as observers, play a crucial role. Our existence and what we observe, according to Hawking, actively shapes the universe we see. In simple words, the universe is a canvas and we're all painters. Sounds very cool and insane, but hey, many things in science were considered crazy before they turned out to be true. So, is there another copy of you somewhere watching this video and who just pressed the like button? Who knows? If there are infinite copies of us, scientists assume that we might be like identical twins, sharing the same origins and starting from one thing, but then developing into separate different people. And if these worlds exist, perhaps we could even visit them one day. There could be some connections between us, something that could allow for interdimensional travel, for example, wormholes. Well, whatever the truth may be, let's hope that one day we'll discover it. Until then, stay curious.
NASA has recently revealed some eerie cosmic sounds that go against the popular misconception about the muteness of space. This discovery proves once again that the universe is far from silent. The revelation came from the Perseus galaxy cluster, located 250 million light-years away from Earth. There, NASA uncovered an unworldly howling coming from the supermassive black hole at its center. This discovery isn't super fresh. It was made in 2003. It marked the first time scientists detected an acoustic phenomenon from such a distant source. Sadly, the sound was not something you would be able to hear. Its frequency was just too low for the human ear to register. The lowest pitch the human ear can perceive is 20 Hz, 20 cycles per second. But the sound emitted by the black hole is a B-flat, 57 octaves below middle C, with a frequency of 10 million years. But NASA brought it to the realm of human hearing in 2022, turning that invisible sound into something you could actually experience. It was a breakthrough of cosmic proportions when NASA revealed that sound waves could travel through space, specifically through the medium of the Perseus galaxy cluster. This medium is a hot, dense gas, something far more substantial than the empty vacuum between galaxies. That's how sound waves manage to travel there. Those sound waves produced by the supermassive black hole at the center of Perseus resonate through the hot gas as ripples. It's like how sound travels through water here on Earth. The thing is, space is indeed a vacuum, which means that sound cannot travel through it, in the traditional sense. But the gas surrounding the black hole in Perseus provided the perfect environment for sound to travel. The black hole's powerful jets create ripples, sending vibrations through the gas. And NASA scientists have identified those vibrations as a type of cosmic sound. Previously, it was totally invisible and unhearable. But now, for the first time, astronomers have helped it to take a form humans can hear. To give us a sense of how deep this sound is, NASA raised its pitch by 57 octaves so that it could finally be audible to the human ear. The result is a haunting, bass-heavy hum. It feels as though it is resonating from the very core of space itself. What NASA did is called sonification. This process involves mapping the characteristics of the data to audible sound. As a result, we can experience something that is otherwise beyond our perception. See those brighter areas of the cluster? They produce louder and higher-pitched tones. The sonification of the Perseus black hole isn't just a scientific discovery. It has allowed us to see, or should I say, hear, the universe in a completely different way. NASA has used this technique on several different space objects, including stars, nebulae, and galaxies, giving us a glimpse into the various ways space can sound. One of the coolest NASA's sonifications is Cassiopeia A. It's the remains of a star spotted as a supernova more than 300 years ago. Located around 10,000 light-years away from Earth, this shattered remnant of a once massive star has a neutron star at its core. And it's the youngest neutron star in our galaxy that we know about. To perform the sonification of Cassiopeia A, NASA took the data captured by the Chandra X-ray Observatory and translated it into sound. Starting at the center, a triangle-shaped tone marks the location of the neutron star. Then, the sound spreads outward, which represents the expanding debris field. That's when the pitch rises and the tones become brighter. The sound grows louder and seems to mirror the outbursts of the supernova and the formation of new elements. The Tarantula Nebula, located in the Large Magellanic Cloud, is a hotbed of star formation and one of the most active regions in the universe. Astronomers have been studying this nebula for a long time to learn more about how stars are born and evolve. So, no wonder that NASA scientists have been doing their best to translate the data from the nebula into sound. They've been mapping brightness and pitch to various features in the nebula. So, airy, synthesizer-like tones represent the chaotic and hot gases surrounding the most massive stars. And the cooler gases that are forming new stars have soft, low notes. Piano-like tones correspond to the brightest stars. And the central cluster of stars sounds like a rain stick. Interestingly, NASA's investigation into the sounds of space doesn't just involve cosmic phenomena. It's also based on the experiences of astronauts, and some of them are truly eerie. After all, space exploration is always filled with unexpected surprises, and sometimes those surprises come in the form of strange noises aboard spacecraft. One such incident occurred aboard the International Space Station, when astronaut Butch Wilmore reported hearing a strange noise coming from Boeing's Starliner spacecraft. By that time, this spaceship had been docked at the station for almost 3 months. The Starliner had just completed an 8-day mission that went awry. The technical issues have been plaguing the spacecraft ever since. Wilmore described the sound as a pulsing noise, similar to a sonar ping. It was coming through the spacecraft's speaker system. This strange noise made Wilmore contact NASA's Johnson Space Center in Houston. Of course, Mission Control immediately began investigating. They were able to listen to the audio inside the Starliner. Wilmore even held his microphone up to the speaker so that NASA could hear it more clearly. The people in charge of the investigation finally identified the source of the noise. They announced there was an audio configuration issue with the ISS's complex communication system. The thing is, this system connects numerous spacecraft and modules, and such configurations can sometimes lead to strange noises. NASA reassured everyone that such an issue wasn't really unusual. At the same time, they encourage astronauts to report any unexpected sounds they come across. At the same time, this incident was just another proof of how tricky it is to maintain advanced spacecraft systems in orbit. The Starliner had already faced serious delays and setbacks, and every new issue added extra pressure. Everyone was worried about the spacecraft's safe return to Earth. In any case, it's not the only incident involving eerie space sounds. In 1969, during the Apollo 10 mission, astronauts heard something truly bizarre while orbiting the Moon. Now, Apollo 10 was a dry run for the historic Apollo 11 moon landing. This mission involved astronauts Thomas Stafford, John Young, and Eugene Cernan. They were testing the systems of the lunar module. Everything was going smoothly, and then they started passing behind the Moon. In that region, radio signals from Earth couldn't reach them. At that point, they all started hearing a strange, high-pitched whistling sound. It was coming through their headsets. The origin of this noise baffled the astronauts since it wasn't supposed to exist in the near vacuum of space. At first, they simply joked that it sounded like outer space music. But in reality, the situation was quite unnerving. The astronauts were on the dark side of the Moon, far away from Earth and any help. And now there was also that eerie, mysterious sound they couldn't explain. At the same time, NASA was super worried about astronauts' health and mental condition. So the crew didn't immediately report the noise to Mission Control. But after they returned to Earth, NASA engineers thoroughly investigated the phenomenon. They came to the conclusion that the sound had most likely come from the spacecraft's communications system. The reason could be the unusual circumstances of the mission. After all, the spacecraft was kinda cut off Earth. The moon was between it and our planet. Still, even after this extensive analysis, the origin and nature of the whistle is still a great mystery for many people. Anyway, all these new discoveries and old cosmic puzzles prove that the universe is far from silent. It hums, roars, whispers, and reveals the mysteries of the cosmos one note at a time. In the future, as our technological abilities continue to evolve, NASA's work with sonification and its study of strange astronaut experiences will likely lead to even more awesome discoveries. And if we listen more closely, we may find that the universe is much more talkative